Hello boys and girls, and welcome to lesson 3-1. This is on greatest common factor, so I'm going to go ahead and put that title on my notes. Greatest common factor, page this is going to be for me page 14. I'm going to skip a line here so I can put 3-1 greatest common factor. Make sure you add that to your notebook if you don't have it already. Okay. So for the greatest common factor, I want you to take down a term. GCF, greatest common factor. Greatest common factor is a set of two or more whole numbers or more whole numbers or rather when you have a set of two or more whole numbers, the largest number that is a factor of all the numbers in a set. So I'll let you copy that down while I explain. The greatest common factor is when you have a set of two or more whole numbers. The largest number that is a factor of all the numbers in a set would be your greatest common factor. So let me give you an example to explain. This is going to be example A. There's a couple different ways we can find the greatest common factor. One of the ways we can do that is to find the prime factors of the numbers. So let's say we want to find the greatest common factor of 24 and 36. I could find the prime factors of each of these numbers. So for 24, I'm going to use a factor tree. 2 times 12 is 24. 2 is prime. 2 times 6 is 12. 2 is prime. 2 times 3 is 6. So these are my primes. 2, 2, 2, and 3. Or we can write this as 2 to the third power times 3. Now I'm going to find the prime factors of 36. I know that 6 times 36, or 6 times 6 is 36, and that 6 is 2 times 3. So my prime factors are 2 times 2 times 3 times 3, or 2 to the second power times 3 to the second power. So these are the prime factors. Now to find the greatest common factor between these two numbers, 24 and 36, when I'm looking at the primes, I want to notice which primes they have in common, or which primes are in both 24 and 36. So I have these two, I have these two, and then I don't have any more 2's in this number. So I'm going to stop here. 2 times 2. Looking at the next higher digit, I have a 3. 3 is a prime factor of 24, and it's also a prime factor of 36. This 3 and this 3 go together. So I'm going to add that down here. So now if I take the factors, the prime factors that they have in common, and I multiply them together, 2 times 2 is 4, 4 times 3 is 12, then my greatest common factor is 12. That means that for both 24 and 36, the greatest number that can be a factor of both of these numbers is 12. In this case, 2 times 12 is 24. And in this case, 3 times 12 is 36. But 12 is the largest factor that they have in common. Greatest common factor. Pause right here if you need to catch up in your note taking. Now, I said there are 2 ways to figure out the greatest common factor, and the second way is to list all the factors, not just the prime factors. So let's look at example B. And for this example, I'm going to find the greatest common factor of 24 and 40. Now, in this method, I'm not concerned with the prime factors. I want to list all the factors out. And the way we do this, 24, put a colon symbol there. And I want to say, okay, well, what numbers are factors of 24? What number times another number is 24? Well, I know 1 and 24 are factors. You start with the smallest one. 1 is a factor of 24 when I do 1 times 24. And so you space them out on the 2 ends, and you're going to work your way inward. The next biggest factor I'm going to try is 2. 2 goes into 24. It would go in 12 times. So I'm going to list 2, and then I'm going to list 12. You're kind of creating this rainbow effect, if you can kind of picture that in your head. Now I need to try the next biggest number, which is 3. 3 goes into 24. Three goes into 24 8 times. So 3 times 8 is 24. Next biggest number would be 4. 4 goes into 24 6 times. And the only number left between 4 and 6 is 5. 5 is not a factor of 24, so I'm just going to go ahead and put my last comma in here. So these are all of the factors of 24. Now I'm going to look at all the factors of 40. Same type of rainbow scenario here, starting with 1 and 40. And I'm going to predict I might need a little bit more space with this one. We shall see. Next, I'm going to multiply 2. 2 is a factor of 40. 2 times 20 is 40. Next, I would try 3, except 3 is not a factor of 40. If I actually work it out, 40, 3, 3, 1, 0, I'm going to get a remainder here. So it's not a factor. And this is the way you would prove that it's not a factor. So if there was a question that said, how do you know that 3 is not a factor of 40, I might show this work and say, well, it can't be a factor because there's a remainder. It doesn't evenly divide into the number. So I can't use 3 here. But I can use 4. 4 is a factor of 40. 4 times 10 is 40. Next number to try is 5. 5 goes into 40. 5, 8 times. And then in between the 5 and the 8 is 6. 6 is not a factor of 40. 7 is not a factor of 40. I'm going to add my comma there. So now I've got this rainbow going this way. The 1 is connected to the 40, 2 is connected to the 20, so forth, and so on. You can call it a double rainbow. Now, when I am trying to find the greatest common factor, it means I need to find the greatest factor that they have in common. They both need to have this number as a factor. So you start on the right-hand side, noticing that we have a 40 and a 24, and they are not the same. So we're going to continue to look to see if we can find one that is the same. 20 is not the same. 12, there's no 12s in 40. There's no 10s in 24, but when you get to 8, you notice that they both have 8. And you can double check and see this is the greatest factor that they have in common. So for the greatest common factor of 24 and 40, you could say that 8 is the greatest common factor. You've just learned 2 ways of solving for greatest common factor. I'd like you to practice that on a separate sheet of paper, and I look forward to seeing your answers to our quiz. Have a great day.